Welcome, everybody. Today we'll talk about iterables. That includes list, bubbles, strings, and other stuff. First, what is iterable? Iterable is a collection of items. These items can be values, simple values, or objects, as we talked about that earlier in the data types video. And this collection we can loop through one at a time. This is an iterable. We can think which can loop through one at a time. The key characteristics of an iterable is that it contains multiple items sorted together. Sorted means they have a relative order. One is behind the other and before the third. So we have relative order, and you can access them individually by position. This position can also called index. And this is called indexing, or can access a slice of them together. This is called slicing, or you can loop through each of them one by one using the for loop. So they can be accessed one item by addition, is indexing. A group of item, a slice of item is called slicing, or iteratively, it's called iteration. And hence the name iterable. Some common iterables in Python are strings, lists, tuples, ranges, dictionaries, sets. We'll talk about them through our course and next course as well. Okay. We have some real world examples of iterables. We have a shopping list. They contain milk, bread, eggs, something else. We have coordinates. So I have 3D coordinates of an item, X, Y, and Z, or maybe 2D coordinates, X, Y only. In a sentence, we have a text. We have a text of a sentence, like to be or not to be, that is the question. This is an iteration, an iterable sequence of characters in a sentence. Objects in general and iterables specifically can be mutable or immutable. What does that mean? Things that are mutable, like shopping cart or class roster or daily or to do tasks daily, and things that are immutable, that cannot be changed, like birth date, months in a year, and GPS coordinates of an object, a fixed object, a building, or a full name. What does that mean? Mutable objects can be modified after creation. Immutable objects cannot be modified after creation. So these collections of the mutable and immutable objects can change by growing, shrinking, and modification. You can add, modify, add, remove, or modify elements. So, for example, student roster, class roster, can have one student added or one student dropped. You also have daily to-do tasks. The tasks can be added, or some of them can be changed from not done into done. So they can be added, removed, or modified. Well, things that cannot be modified after creation, like birth date. So you have been born once only, and your birth date can never change, or should never change. The months of the year are 12. They will not be 13 tomorrow and 15 yesterday. Coordinates describe a fixed position, fixed location, should not change. A person's name is a text, a fixed text, not replaceable letters. So your name, if you are Mr. Gray, Grey, cannot be Gray, Gray tomorrow. So the bottom line is that if the mutable objects are fixed, if you want to change them, you will need to create a whole new project, a whole new object, sorry, which is not efficient. So they are mutable if you need to change any of them. While the immutable objects, um, immutability guarantees that this will not accidentally change. So this is more fixed and stable and predictable. Okay. Now we said there are iterables. How are the iterables created? Here today we talk about three iterables: list, tuple, and string. List is simply a comma separated, written as comma separated items between square brackets. So a variable called precedence since 2009 may contain four variables for objects: string Obama, Trump, Biden, and Trump again. Um, After 3 years from now, there will be maybe a fifth name. There will definitely be a fifth name added to the string. So there is addition. So anyway, the bottom line here is that it's written as comma separated values between square brackets. The tuple is very similar. It's also comma separated items, but between parentheses. So it's between square brackets is a list. Between parentheses is a tuple. The third iterable is string. The string is simply characters written between pairs of single quotes or of double quotes. Python doesn't differentiate between single quote and double quote. Precisely, it accepts both single quotes and double quotes. So you can enter something single or between single quotes or between double quotes. This is wrong. I will need to change this later. Okay. So it should be a set of this. Let me do it right now. Okay. Okay. Now we talked about list, tuple, and string. Uh, List and tuple are very similar to each other. The only difference between them is that tuple is immutable while list is mutable. String is similar but not exactly the same. So when shall we use each type of these iterables? The list is mutable and heterogeneous content, which means the contents are not necessarily of the same type. So that's suitable for collecting items that accept addition, deletion, and modification. For example, I have a list of months, we'll call months till next year. We are now in March, so the months till next year are April, May, June, July, until December, from 4 to 12. This list changes once per month. So next month, when we are in April, it will start with May. April will be dropped. So this list is mutable. On the other side, a tuple is immutable. It also contains heterogeneous contents. So this is suitable for collecting items that don't change after creation because it's immutable. So months in a year is always fixed with numbers from 1 to 12. Compare this to months till next year. This is changeable. So months in a year are suitable to be in a tuple, while months till next year suitable for a list. The third is a string. String is 0 or more characters. All of its contents are characters, so they are the same type. That's why it's called homogeneous. Same type. All of them are characters. Okay, this is suitable for names, text, things that are textual in nature. So a variable Donald J. Trump, Joe Biden. After 3 years, we will know who will be. Okay. Uh, What are the contents of the iterable? We said that the string is homogeneous, contains character, and the collection, the list and table are heterogeneous. So what can be there can be collection of items of anything, any collection of items. This item can be values like integer, float, boolean, can be objects, can be other iterables as well. So a shopping order can be represented as a list containing the order number A102, the contents, milk and bread, the shipping information, standard shipping using USPS, and the payment status being false. After 1 hour, it will be paid, so this can be changed into true. So this is mutable contents, and the contents don't have to be of the same order. It can be anything as including iterables. So if here we see that milk and bread is a list, standard shipping and USPS is a tuple. Both of them are items within a list. So the iterable can contain anything, including other iterables. The same here. Tuple as a collection of items, very similar to the other one. Um, um, and they contain also other iterables or other objects. So a transaction, but not changeable. So transaction once created, it will not be changed. So if you have a transaction that has been done on the 31st of January 2026 at 11:25 a.m. With a content of 1,000 from Amr to Alice. This is a transaction, a tuple that cannot be changed later. Once created, it cannot be changed uh, any further. Contains floating value, strings containing a tuple for the timestamp. The date timestamp. The date timestamp contains date on 3 items and time on 1 item. So it's containing other objects, and these objects can be other iterables as well. Strings is simple and straightforward as characters from Unicode or ASCII table. If you don't remember what is an ASCII table, go back to the data type video and the Boolean video. Okay, so it can be I have a dream between double quotes or single quote. It will not be a problem. I have a dream, and dot. Dot is also a character. Doesn't have to be only. Doesn't have to be only letters. Okay, before we go any further, let's test these things and try them on the IDE. Okay. We import the date time from time just because we need it later. Let's run these lines. So we created shopping list as a list between brackets, coordinates, between parentheses, and a sentence to be or not to be, that's the question, between double quotes. We print them. Let's see how them are printed. When Python interpreter prints a string, it doesn't add the quotes unless we say print represent of sentence. Let's read it again. Now the representation of a string is string between double quotes. Sorry, single quotes. Okay, we don't need it, so we'll not include it anymore. So just to know that a string is printed without the single quotes, unless we instruct the interpreter to do it. How iterables are created? Let's also show this. Items are created. Um, List is created between uh, square brackets, coordinates of the greater Giza pyramid, created between parentheses. By the way, this is a real coordinate of Giza pyramid, and this number is almost is the speed of light in kilometers per second. And first full name, using single quote or double quote, they are the same. They produce the same result. Okay, let's go down more. When to use each type. Months till next year. Starting from here, you have 4, 5, 6, 7, 8 until 12. But once in a year, from 1 to 12. Current President Donald J. Trump. Uh, can we change the months of the next of the year? Yes, we can. Let's say here, print after change after 1 month. Something next year. Months until in a months until till next year. Dot Bob 0. So we remove one element and print it again. You add these two just above this one. Print again, run again. Sorry, it should be above this line, not below this line. I should print this first. Okay, let's do it. So 4, 5, 6, 7, 8 until 12. After a month, it will be 5, 6, 8 until 12 only. Okay, but if we try to change anything in these, months in a year, if we try even to change it, the ID will complain. Segments in a year of 3 equals, let's say, 0. Say the yellow highlight. Bubbles don't support item assignment. Okay, and if we force it to run, it will break. Double object don't support item assignment. Okay, so there's not supported. Also string. We can change the whole value of the variable, but you cannot modify the content. Suppose I'll say a current president of 2, which is n equals, say, x. If you see here, there is character class string doesn't define a set item, so the square bracket operator can't be used in this instance. If we try to do it, it will also complain. Okay, now no complaints. Nice. So we finish this. Now it's also we have to test another. Yeah. Okay, let's run this. So what elements can iterable contain? The list can contain a string, can contain another list, tuple, boolean, and this list can contain two strings, and the tuple can contain two strings as well. Okay. This is a list. This is a tuple between single brackets. This is a string that we said it will not be printed with a double quote or single quote until we instruct the interpreter to print it. Now the content false can become true, and everybody's happy. Nobody complains. Other than this, the same thing is not changed. Everybody's happy. Okay, next. Common operations that can be done on iterables. First operation is concatenation. This is straightforward. A string that contains two items plus a string that contains one item, sorry, a list containing two items plus a list containing one item can be a new list containing three items. The tuple that contains two items plus a tuple containing two items will be a new tuple that contains the four items. String hello plus string space plus string word can become hello world. Straightforward. Let's try that. Milk, bread, and egg, one string, one list. 1, 2, 3, 4 in one list. Hello world in one list. Okay. Notice that concatenation produces a new object. It does not. This is plus. Is not plus equal. Let's try to play with plus equal. See whether it will work or not. Say lst1 lst yes 1 equals bit 2 x is now lst equals lst1 and 4. This is a new object. This is a new object. Again, this is a new object. lst1 and 2 are the same. Now lst1 comma lst2 print lst3. Print lst1. Create worker. No. Before plus equals. After zero. Like that. So we compare two strings before plus two strings, one big string, which is a string coming, which is lst3, which is before plus before plus here, these two, lst1, lst2, separate, separate with space, and then lst both of them, and then lst1 plus equal lst2 plus equal now lst1 has been modified. So the bottom line here is that plus does not modify. Plus creates a new object containing both contents, but not modify the first one. To modify the first one, you need to make an assignment. So it can be either plus equal or can be lst1 equals lst1 plus lst2. Okay. Now let's finish all of this. It's beyond the course content. Operation which is concatenation with plus. Second operation, indexing. Most of them are related. So indexing ordered index, also known as position. This is start from 0, not from 1. This is a common feature in programming languages. They start from 0, not from 1. The first index is not 1. It's always called 0. That means if we have 10 objects, 10 items, it will not be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, not 10. Okay? So this is the length of iterables minus 1. From 0 to length minus 1. Items can be accessed using the square bracket operator. Notice that this is very similar to the square bracket operator, which represents the list content, the list itself. But this is not the same. They are similar but not the same. Notice that in computer science we always tend to use as least as possible number of operators. So they are similar but not the same. This is this square bracket operator here represents accessing, addressing, while in other contexts it represents formation of a string, a list. So items can be accessed using the square bracket operator. Accessing a single item is called indexing, while accessing more than one item together is called slicing. We talked about that a little earlier. Okay, let's start with indexing. Indexing in Python starts from 0, as we said. The string, if you have a string, here we have a string Python, represented as a sequence of characters of 6 element long, indexed from 0 to 5. The capital B is 0, the N is 5. Also, we have a list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, represented as a sequence of integers of 10 lengths, 10 element long, indexed from 0 to 9. Notice here that the index is from 0 to 9, the content are integers from 1 to 10, but that doesn't always have to be the same. It can be characters, it can be anything. Okay. We'll work with these two iterables for a while. So Python Python from the string from 0 to 5, and list one from containing the numbers from 1 to 10. If we print the item number 0 of string 1, what is item number 0? The first item is a capital P. Print the capital P. The item number 4, or actually is the fifth item. Remember that. It will be the O. Item number 6, which is actually the sixth item. Item number five, which is actually the sixth item, is the last one here, which is the N. What will happen if we request items that is beyond the limit? It will get an error. Okay. And does the same apply to the list as well? Yes. Uh, Similarly, printing list item, first item, number 0, reduces 1. Again, this is the indexing. This is the index. This is the content. Item number 0 is 1. Not number 0 is 0. Okay. Here number 0 is P. So there's no relation between the index and the content. First index, number 0, content 1. Fifth index, number 4, contains 5. 10th index, which is number 9, contains 10. And if we try to print something beyond 9, it will produce an error. Let's try that. Negative. Let's try that. Okay. We have str1 and list1. Print them. P, O, N, which are items 0, 5, and 9, 0, 4, and 5, and 1, 5, and 10, which are 0, 6, and 9. What will happen if we try to print item number 6, which doesn't exist? There's an error. Exit code 1. There's an error. It didn't print it to me. It should be printed somewhere. Ah, yes. Here is error. Okay, saying that string index out of range. The same here occurs if we try to print a list index that's out of range. List index out of range would be listed, and here is the indicator to where it is. You see? Okay. We don't accept this 10 because the last item is 9, from 0 to 9. Okay, let's hash this out as well. So we have seen indexing, natural indexing. Now, next is a really nice, famous, nice feature in Python. Again, we have string 1 and string 2, the same strings, string 1 and list 1, the same. Python can also index from the back. If I want the last item here I can print it normally as str1 of len of str1 minus 1, because the length is 10 or 6. The length is 6 minus 1 is last element. This will print in. Here is another nice fine method. By negative indexing, we have two indices for this that represent the same location. We can count from back: -1, -2, -3, -4, -5, -6, and here it's -7, -8, -9, -10. This exactly um, conforms to -1, conforms to len of the iterator -1. So if you want the last character here, which is the n, we can say print str1 of len of str1 -1, or simply print str1 of -1 directly. So -1 here, -1 here. We don't need to write the length of the iterable. Isn't it easier? I believe so. Yes, it is. Does it apply to strings only? No, applies to everything. Also, also you can apply to string. No, this is list. Needs to be corrected. Okay, I corrected. So also list one, which is this one, of -6. This is -6. -6, which varies to element number 5, continues the content 5, bins 5. So we tried -1, -2 here is the next, so is the next last element. O here -1 is last element, which is 10. -6, P, capital P. Here -10 reduces 1. If we write anything that's beyond, if you try and index anything beyond minus the length, -10 here or -6 here, it will get an error or an error. So -7 here is an error, -11 here is an error. Okay, so when indexing, you have to be precise. Only use the numbers from minus length up to length -1, including 0. That was about indexing. Now talking about slicing. For similarity, for simplicity, in the following slides, I will be mainly using only the list to represent the slicing, but anything that applies to list applies to list, tuple, string, range later, anything. Okay, nice. Now we know for indexing we use index between two square brackets, sorry. For slicing we use start index inclusive and end index exclusive, and the step separated by colons, and within also within square brackets. You can think of start inclusive and end inclusive as first element to include and the first element to exclude. You can think about it two ways. Step also, of course, is in two cases. Okay? So the start is inclusive. It's easy to think about it. It's first element to include. Start end exclusive is the first element to exclude, not to include in your slicing. We'll see about it. Now, what's the meaning of slicing? Slicing is like when you take a slice of pizza or slice of cheese out of the whole bar, slice of rice. Sorry, slice of bread, slice of bread, or maybe you can take two slices. We'll see it. Nice. So, yeah, as I said, for slicing, we use start inclusive and end exclusive and the steps, split by column. The default start is 0, and the default end is length of the list itself, or iterable if it's not list, and the default step is 1. If you have list 1, the same list 1, we're going to it with it throughout the presentation. List 1 including the number from 1 to 10. So list 1 of 0 colon 5. 5 is the 6th element. This is exclusive. So we have the first 5 elements. So 0 to 5 is the first 5 elements, excluding the 6th element, which is number 5. Will produce 1, 2, 3, 4, 5. Okay. You can also start from 5 to 10. Meaning starting from the 6th element inclusive to 10. So notice that here that the same 5, if you use the same 5, if you have the same 5 in both um, um, uh, strings, as in both slices, you will get with everything. What you exclude in the first sentence or expression will include in the second expression. So what do you think? Print list of list 1 of from 0 to 5 plus list 1 of 5 to 10 do. What do you think? As we said earlier, concatenation makes a new object containing all of the items from the first one, all the items second one in one object. If you print the newly created object, it will contain the whole number from 1, all the whole content from 1 to 10. Similarly, string 1 includes Python. So from string 1 from 0 to 4, which is the fifth item, includes the first 4 elements, capital P, Y, T, H. From Y to 6 is includes save of 4 of fifth, which is O, and if 6, which is N, and exclusive of the 7, which is 6. So there's nothing actually behind this. So this is the length of the string. So it will, if we do the same here, it will be Python. Let's test that. We didn't test technical indexing. We didn't test technical indexing. Okay, let's test technical indexing first before we go. Okay. The first two show that len of string 1 minus 1 just gives the same value like minus 1. Minus 1 only gives the same value as len of string 1 minus 1. Okay. We got the first element from the back, second element from the back, sixth element from the back, which is actually the first element. NOP and 501. Okay. And if we include this, we'll get an error. Here it would be string index out of range, and this will be list index out of range. Let's try them. It will stop at the first error, code number 1. String index out of range. Okay, let's have this out. We'll for in the second. Again, list index out of range. Okay, nice. This out and show the next slicing basics. So from 0 to 5 reduces 1, 2, 3, 4, 5. From 5 to 10 reduces 6, 7, 9, 8, 6, 7, 8, 9, 10. And both together will produce a new string, a new list containing all of them. Python, we use Python. Okay. Let's go back to next question, which is you can also slice using negative indexes. As we do with indexing, just use them for slices. So you can try to print slice from the beginning, excluding the last two elements. As I said earlier, from 0 to len of list minus 2, or in a better way, just say minus 2. Okay. If we need to take the second last element only, it will be, which means I only need this 9. So it's from minus 2 going to and excluding minus 1. So it will be only minus 2. Okay. This is very similar to indexing minus 2 only. If we want to slice the, we can say minus 2 up to the. Now here notice that I used a len of string 1. Can I write here minus 2 minus 1, so this could be 0. I use 0. No, because 0 means the first element, which is this one. Okay. Use 0 because 0 means first one. So how, if I want to make it easier, what can I do? Next slide. I can omit the first or the second parameter if they can be deduced. So if I want the slice the first element, instead of writing list 1 of 0 to 5, I can just say list 1 of empty to 5. Here empty means the first one. Remember that there are 3 default values: beginning, end, and 1, or start, end, and step. So I can just write list 1 of empty colon 5. I want from the 6th element onwards till the end, I can write from this is what we have seen in the slide, from 5 to len of list 1. I can just say from 5 to empty. It will handle it. If I want to slice, this is the one which we was in the previous slide. If I want to slice from the beginning, excluding the last two elements, so just say empty up to minus 2. Here, excluding the last two element from 0 to minus 2. Notice that first we said from 0 to len of list of 1 minus 2. Then we simplify it into 0 to minus 2. Now we're simplifying it even further. Just empty to minus 2. Isn't Python nice? Yeah, I believe it does. It is. Okay, slicing class 2 elements in an even better way. You can say from minus 2 empty, instead of writing minus 2 to len of list one. Remember that we couldn't write 0 because 0 means the first element. Okay. Now, what do you think this expression mean? List one of empty colon empty. What do you think? List is that. I think with negative indexes. Negative indexes from 0 to list of -2 excludes 9 and 10. Just saying from 0 to -2 without len of, without this len of list 1, just writing -2, it will give the same result. Okay, from -2 to -1, we reduce a list containing only 9. And list of -2 to len will reduce the last 2. Okay, I have here one point. I said something which I don't want to be misunderstood earlier. I said that this production is similar to indexing element number -2. However, it's not exactly correct because indexing produces an element while uh, while slicing produces a slice containing an element. So the difference. Print indexing list 1 -2 slicing list 1 of -2 to -1. So what will happen now? This is 9, an element. This is 9 within, sorry, this is 9 within a list. So list containing one element. So this is the difference. Indexing produces the element. Slicing produces a new iterable. Slicing a list produces a sublist. Slicing string produces a substring. So what do you think slicing a tuple will produce? You answer. Okay. Next. Now, playing with stride. Playing with step. Step is a stride between items to select. If you want to slice only the even index elements, that means in index number 0, 2, 4, 6, 8, and that's all. You can select list 1 of empty, colon empty, colon 2. This will reduce 1, 3, 5, 7, 9. Now, notice something. I'm talking about even index elements. I don't say even elements. There's no relation between index and the content. Simply, the content can be anything, literally anything. It can be a string. The content here is a character. So capital P or small y or small t, this is not an integer that can be even or odd. Okay, so we're talking about even index, even number. We do the same here in the string. So str1 of empty is the connection working fine? I record on the internet. So str of empty2 produces a substring containing p t o, which is a characters number 0, 2, and 4. Sliding the odd index
elements. Now we know. What about odd index?
Okay, they are number 1, 3, 5, 7, and 9, which are numbers 2, 4, 6, 8, and 10. We just start from 1 instead of starting from empty, which means 0 in this case. Start from 1 and go skip 1 each time, so go to 2 by 2. So 2, 4, 6, 8, 9, 8, 10. Doing the same for a string will produces a string with YHN. Again, this is wrong. I will need to correct it later. Now it's your time to say, to answer. What does this line select? First one, starting 1 inclusive and -2 exclusive with stride of 3. Let's do it together. Starting with object 1, so the first element is 2, up to -2, which is here, 9 exclusive, so the last one will be actually here. So from 2 to 8 with a stride of 3. So 2, skip, 5, skip, 8. Anymore? Nothing more. So that's right. It will produce a list with 2, 5, and 8. Let's test that before we go further. Omitting slice parameters. Uh, from 0 to 5 produces the same result as empty to 5. Again, from 5 to len of list 1 with the same result as 5 to empty. So from 1 to 5, from 6 to 10 in both cases. From empty to -2 excludes the last two elements, 9 and 10. From -2 to the end, the last elements only, two elements only, 9 and 10. From empty to empty means everything. So from 1 to 10. Slicing with a step. One. Empty 2 will produce the even index values, which are the odd numbers 1, 3, 5, 6, 9. Index 2, empty 2 of the string will be TO. Starting from 1 will produce 2, 6, 2, 4, 6, 8, 9, and YHN. And finally, from 1 to -2, step 3 will produce 2, 5, and 8. Okay. Next step could be negative. Yeah, that means we are going from back forwards. That reverses the order of all the elements. So if you want to reverse, if you want to reverse order of all elements, so just say empty -1 will produce 10, 9, 8, 7, this repeated 8, 7, 6, 5, 4, 3, 2, 1. Let me correct it. Okay, corrected. So list one of empty -1 will produce 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. String one of empty -1 will produce no cheap, Python in reverse order. Now, let's ask this question. We cannot say empty 0 -1 because the end is exclusive. So if we use 0, it will end up down to 2. It will end down to 2. There's no 1. and here will be no P. We also cannot write -1. Why? Because -1, you know it, is here. Okay. So if we start from anywhere down to the last one in reverse order, it will end up with an empty result. So produce empty string. -1, -1. Empty -1 will produce empty string. Because you cannot go from anywhere to the last element backward. So if you want, this is the first note. So remember that if you want to slice something from backward, and you want to end up containing everything, just leave the second parameter empty, not zero, not -1. Okay. Now, if we want to add to get the even or odd numbers, slicing negatively from using backward, we need to take care of the start element. For example, when we wanted to add to get the even index numbers going forward, we just wrote list one of nt2 -2. Sorry, nt2. This produced the indices number 0, 2, 4, 8, 6, 4, 6, 8, which are 1, 3, 5, 7, 9. However, if we wrote nt -2, we will get 10, 8, 6, 4, 2, which happens because we start from here. Now, 9 is an odd number. We don't get the same result as we start from here. Okay, this is the reverse of the odd number not index element, not the reverse of the even index element. If we just use -2. So how to fix that? This will be your assignment. Let me give you a hint. You can either get the even index element first and then reverse them. This is the easier way. Or make sure that you start from an even index from backward. This is harder, but it's more efficient. Why more efficient? Because getting the whole index, whole indices from the start, starting with an even number until the end, and then reverting them. This could be easy for 10 elements, but if the number is 10 million elements, it will not be efficient. Okay. Anyway, for your level, both of them are fine and accepted. Okay, let's try that. Negative steps and reversing. Empty -1. This is from 10 to 1. String 1 of empty -1 produces from n to p. Using empty 0 -1 is not right because it will produce the list without the first item, or the string without the first item. This character. Okay. Sorry, this one. Print string 1 of empty -1. If you're going backwards, you can never end up excluding the first element. Come back, I mean. So this will end up with an empty string. Empty. You see? Empty string. Nothing here. And empty minus 2 produces the reverse of the odd elements because we end up with odd number. Okay. Your assignment will be do this. Finally, I need to give you some information. This information is that slicing is more tolerant than indexing. In indexing, if you write something that is out of range, you will get an error. So list one of this list one from 0 to 9. If you write something like 20, you get an error, and you have seen that already. List index out of error or string index out of error. List string index out of range. String
range error. If you select out of range element or elements accordingly in a slice, it will give you as much as possible. It will not produce an error. So if you try something like list 1 of 5 to 20, step 2, 5 is a 6th element. We know how to read that already. From here,
starting from here up to 20. There's no 20. So to give you as much as it can. Step 2 is 6, skip 8, skip 10. So 6, 8, 10. If you start from 10 going to 120, there's nothing here called 220. So it will give you an empty string. The same if you start from minus 100 to minus 120, or minus 120 and minus three of them will produce empty strings because there's nothing beyond the range minus 10 to 9. Okay. If you say from minus 1, which is here, to minus 20, which is something very far here, not in the range, still minus 1, it will give you as much as it can until its end, which is actually the start. So from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and stop here, which is actually pretty the full length. It will not complain because the minus 20 is out of range. Although here, yeah, here if you index anything out of range, it will complain and produce errors. So the bottom line is slicing doesn't produce error, but produces as much as possible. Next video will be about iteration using range and for loops. See you then.